Zoom crew. All right. What the heck? Connecting. Sure. Cool. There it goes. Cool. Okay. Let's go ahead and get started. Though we're missing quite a few people today, huh? Dang. Maybe I miscalculated. Maybe I should have had everybody do the voting for future of Game AI topics on Monday. Maybe people have already taken off for reading week. I don't know. We'll see. Anyway, some announcements before we sort of jump into it. Today we are starting on PCG. I should mention. Announcements quiz 4 will be released tomorrow at 11 a.m. If you somehow missed my 3 other announcements about that, tomorrow there will also be an online help session. You can show up there for the quiz, for assignment 4, for whatever, 5 to 8 p.m. It'll be at the regular office hours meet link. There will be no lecture Friday, but again, there will be more online help from 11 a.m. to 1 p.m. So if you're feeling you need help in any of those things, my guess, my bet as a pessimist is that nobody's going to show up for any of these, but we'll see. Maybe somebody will prove me wrong. Quiz 4 is going to be due still at Sunday at 11 a.m. As per always, there's no grace period for the quizzes. And then finally, assignment 4 will be due after reading week, which is the reason why all of these help sessions are happening. But because it is due in a week-ish, I suspect, or over a week, I suspect I will not have anybody show up. After reading week, as a reminder, there's going to be a workshop on demystifying grad school on November 17th from 5 to 7 p.m. The link will be in the slides afterwards. I'm going to keep reminding you all of this until it happens, basically. Every week or so. So I'll do one more a week from today, and then the week of probably. Let's see, how can I, there we go, chat. Will I be available to answer questions on Discord during reading week? An interesting question, which might suggest when you're planning on doing the assignment, but yes, I'll be available. Maybe not super responsive, but I'll be there. Okay, with that, first PQ, which is just the future of Game AI voting. As a reminder, if you've forgotten, the final 4-ish lectures of the class, you all are going to get to pick the topics of, and this is where we do an initial round of voting. You get 4 votes, and you're going to be picking between this list, well, up to 4 votes. For those of you who are just interested in participation points, you can just click once, that's fine. But I'm hoping that people will be interested in some of these topics since I grabbed them from your suggestions. In a second, I'll talk through what each of these are. I'm just going to do my usual copying and pasting text to put in the Discord. Okay, let's talk through these a little bit. So reinforcement learning for games, that's pretty straightforward. It's just going to be a topic on how do we apply reinforcement learning, unsurprisingly, in games to be able to do automatic playing of games. Reinforcement learning, if you're not familiar, is one of the 3 types of machine learning. It's the only type that we didn't touch on in the data science lectures. Automated play testing. So this is this notion of how do we automatically determine if a game is playable or if a game is broken in some way, find bugs, things like that. The approaches here are largely reinforcement learning and automated planning, along with just some other simpler planning approaches. Game AI in academia. So this would just be sort of an overview of like, hey, I'm a professor who does game AI stuff. There's other professors here who do game AI stuff. There's professors all over the world who do game AI stuff. What do they actually do? What's their work like? AI for automated game playing. This is distinct from reinforcement learning from games, because for a lot of games, you don't actually want to just apply reinforcement learning or reinforcement learning on its own. And so this would be a broader overview of like, hey, what's the history of this field and what's the state of the art look like? Balancing game AI. This is related to automated play testing, but is distinct because there's ways that you can do automated play testing to find things like bugs, not necessarily just balance on its own. How AI can change cinematic cutscenes. I included this one because it was a suggestion, and there's some interesting stuff around camera control. But for cinematic cutscenes specifically, not all that interesting, but camera control broadly would be what that lecture is about. Generated dialogue and story, that does what it says on the tin. We're gonna talk a little bit about generating dialogue and story in this PCG section, mostly after reading week. But if you want more, that'd be where that is. And I can also talk about like experimental stuff that is not yet in games. AI-based game design. So this is, what if we design games with AI as the focus, as opposed to AI just being given 10% or whatever of the computing budget. AI for game design, this is distinct. This is, what if we use AI to help us make games, whole games, not just parts of games with PCG. Speaking of PCG, procedural content generation via machine learning. We're going to touch on this very, very little because it's only actually in games to a very small extent right now. But there's a lot of sort of experimental stuff in this area, including my research. Mixed initiative PCG. This is human and AI designing stuff together. Again, we'll talk about this a little bit, including today, but this will be a lot more stuff we can talk about there. And then basically further discussion on any previously covered topic outside of PCG, because there's already a lot of PCG stuff in here. Okay, those are all the options. Yeah. It won't affect the final assignment. You'll note there are 5 assignments and 6 quizzes, right? So it'll impact the last quiz, but the final assignment is just a PCG assignment. Any other questions? Okay. Participants can now see my screen, says Zoom, which is funny because I'm pretty sure they could see it the whole time. Let's see. I'm curious, at least, about what people have started to vote on. If people have even started to vote at all. Let's grab here. All right, 23 responses. Hopefully we get over 1/4 of the class taking part in this. All right, reinforcement learning is the big winner because it's the first thing and people are going to vote a lot for whatever the first thing is. Followed by AI for game design, and then procedural content generation for machine learning, and then with the runner-up of automated play testing. As I said, this is not going to be the final determiner of what topics are covered. We'll probably have to have a second round because, like, right now, if I was just to grab the top 4, right, balancing game AI is like an immediate, very, very close follow-up. So I would want to give people who are voting for some of these other topics, which may not make anywhere close to the top, 6 or 8 or whatever I end up picking, them a chance to have a say. So there will be one more round of voting after reading week. We'll see what happens. Cool. Let's go ahead and keep on moving. So procedural content generation. If you're completely unaware of what PCG is, it is a computationally, apologies, it is the problem of computationally representing a design process. By which I mean, it is a way to represent with computers the process that otherwise humans would do for games. So, right, this is No Man's Sky from Hello Games over here. And No Man's Sky famously generates quote unquote everything, right? So the creatures on the screen are generated, the land mass is generated, the location of this flora is generated, this sort of like little area over here is generated, everything is generated. They have a whole bunch of different like hierarchical constructive generators generating everything. Most games don't go this far. Sometimes you'll have procedural levels or procedural guns, procedural stories, but you don't have everything trying to be generated. It's cool for sure. I think it's super cool. I do most of my research on it, but it has large time and expertise requirements. This goes against the sort of grain when it comes to PCG, particularly about 10 years ago, where everybody was like, PCG, it's the future. If we do PCG, we don't have to do any work on games anymore. It'll just do all the work for us. Not true. It's really hard to get a generator to make good stuff. You're going to see that for assignment 5 yourselves. And it's typically used to create new content for a single game. So when we're talking about PCG systems, they're generally game specific. So I'll be able to talk about high level, what are the kinds of systems that exist, but anytime we were talking about implementation details, it would depend entirely upon the individual game. So it is, again, some algorithmic generation of content. That's what we mean by PCG. And the way that I'm going to break this down is in terms of, for this lecture, in terms of what kind of thing we're generating. So is this game bits? By game bits, I mean essentially pieces of things in the game world, like items, like creatures, etc. Game space. So this is the notion of the space around you, the space you're moving through in a game. That's the notion of game space. And then finally, game scenarios. These are things like story in games, quests in games, missions, etc., etc. I've stolen these terms. This is from a survey on PCG by Hendricks et al. I'm going to put this up at the front. It will also be at the final slide. Recommended reading for this whole section is chapter 4 of Yannickakis and Julius's Artificial Intelligence and Games book. It's freely available. You can find it there. You don't need to buy anything for it. I also want to do a brief shout out to Adil Zafar, who is a recent PhD. I'm trying to get as a postdoc. We'll see if that whole program works out. Anyway, he done a survey on PCG recently, which also informed parts of this. So game bits, that's the sort of first area that I was mentioning here. And we can break this down into a few different things, right? So who here has played one of the Borderlands series? Okay, so some hands. So in Borderlands, right, they famously generate guns. Every gun you're going to get outside of some specific story guns is a generated gun. They have some notions of particular kind of manufacturers, and they're trying to generate guns that could have been produced fictionally in game by those manufacturers, but all of those guns are generated. Who here has heard of Speed Tree? Anybody? Okay, a couple hands. So for those of you who are not familiar, Speed Tree is a third-party piece of software, though it's integrated now into, I think, Unreal. I think Unreal bought it, forget now. Where the basic idea is you can define sort of a notion of trees, of what a tree should look like, and then it will generate you a whole bunch of 3D models of trees that sort of largely fit those design constraints. This is really helpful. So if anybody remembers, like way back in the 90s, before people had things like Speed Tree, every tree in every game was hand modeled, which would mean that you get the same tree over and over and over again, and it was super obvious. Nowadays, if you're just like looking around, walking outside in any open world game, you're going to see unique looking trees all over the place. If you pay attention, you might be able to recognize components, but overall, each of them is the same. And then finally, the already mentioned No Man's Sky, generating, in this case, we're talking about their generation of like the individual creatures and things like that. Okay, so then we get to game space. So here we have Rogue from 1980. If you're not familiar, Rogue was the game that launched the notion of a roguelike, which is an ongoing genre where essentially every time you play it, the game is unique. In this case, it was like a super trivial little like ASCII art game, right? Way back when, where every time the sort of dungeon world that you explored was generated. Has anybody here played Spelunky? Spelunky 2 just came out, so I'm allowed to reference Spelunky. Wow, so few people. This is so sad. Spelunky used to be much more popular, but Spelunky sort of made around 10-ish, 15 years ago, the notion of indie PCG like this really big thing. It was this huge popular game. And because it was so popular, a whole bunch of people tried to sort of rip off it and suggest that like PCG was going to be the future, and with a single person team like in Spelunky, you could produce things as good as AAA. Remnant from the Ashes is just a game that I liked a couple years ago that used PCG. And then we have, of course, this little game known as Minecraft. Probably none of you have heard of this one, right? Very, very unusual, strange little game. But of course, you know, Minecraft, one of the largest games in the world, and every biome, every world, everything is generated in Minecraft every time. So then we get to game scenarios. So these are by far the least common, and they're almost never seen in AAA games. This is the notion of generating stories or missions or things like that, things for the player to do or experience. So Skyrim and a whole bunch of other Bethesda games have these radiant quests, but they're super trivial in terms of generation. They're basically like, hey, go to this location and kill this thing, or kill X of this thing, or whatever, things of this nature. They're very, very simple, and they lead to things like a bear spawning in somebody's house and you have to kill it. Dwarf Fortress. Has anybody heard of Dwarf Fortress? Okay, yeah, so this corner. Dwarf Fortress is this, famously dense game. A new version is coming to Steam that will actually have visuals that a human can understand. But Dwarf Fortress generates history, mythology. It generates what people think about those histories and mythologies, et cetera, et cetera. So a whole big thing. Elsinore, I mentioned before, right, is this sort of planning-based game where the AI agents are sort of planning every time for every change that you make, which ends up producing stories, but it's not intentionally just generating stories on its own, sort of with the player. And then finally, Caves of Cud, which is sort of like an even more indie Dwarf Fortress, essentially, is the way I describe it. Okay, so before we get much further, a big thing that I wanted to get across is that PCG isn't magic. A whole bunch of even practitioners in the indie space will give you lectures where they'll say things like, oh, PCG is like magic. Whoa, it's crazy. Mysticism, etc. You're a digital wizard. And like, no, that's not the case. Essentially what's happening here, right, is you are writing down instructions to someone you will never meet, can create a level, puzzle, or creature, etc. for your video game, right? But in this case, the instructions have to be in code. And the person in this case is just the thing that's executing that code and has no cultural references. So all of the way you define everything, all the instructions have to be super specific to be able to make this work. And sometimes it works, it produces incredible things like these examples that I've given you, and sometimes it entirely trashes games. So Mass Effect Andromeda, if you're not familiar, which is made right up the road at BioWare, was a flop. And part of the reason was they spent 5 years in development, but the majority of the development actually occurred for the final game in the last 18 months. And the big reason for this was that they were trying to get PCG to work. Their original vision for this was a very similar thing to like No Man's Sky or something like that, where you would be playing this sort of like single player campaign, sci-fi hero or heroine, but you'd be in a procedurally generated galaxy every time. So everybody's galaxy would be unique. But this entirely went up against sort of the culture at BioWare in terms of how they did storytelling and how they structured games. And so they basically lost 3.5 years of work, which is a real shame. And here's a Kotaku article, so I can pretend that I learned about this there and not from talking to BioWare people. In comparison, right, we have things like Spelunky, which now I know none of you know about, but Spelunky 2 just came out, so I'm allowed to still make references to this. And it's still historically important. So it was developed in large part by a single person, Derek Yu, and it makes use of this constructed grammar of hand-authored chunks. We'll talk about it more, exactly how it works in a lecture after reading week. But basically, with PCG, he was able to produce a larger game than a single developer could sort of traditionally create. Right? You can play Spelunky basically endlessly. There are still people who play the original Spelunky daily, which is wild, right? This was made by a single person. This was like 10 something years ago, and people are still playing it. If you're particularly interested in the details, there's a book on this topic, and it has a cover, which you're going to laugh at, but it's because there's an item in the game, which is an eggplant. Okay, so there are 3 major methods for PCG. With all that being said, all these notions, there are 3 basic ways behind the scenes that you might be generating PCG levels. The first of these is a constructive method. So in a constructive method, basically we're going to be building up content piece by piece. Think of this like a Lego blocks type approach, where you've authored all the Lego blocks and rules for how they can stick together, like with Legos. But what you're going to do is let the computer actually put things together. Basic idea there. Then you have a search space method. So the idea here is that we're going to define a search space where every single point of the search space is a usable piece of content. And then we're going to basically look across this search space to try to figure out where the best piece of content is using some heuristic, which again is a way of taking in something and getting back a number. Finally, we have machine learning based methods, which is basically to train on some existing data and try to produce novel data, novel content that is similar but not identical. I'm largely not going to talk about this today. Again, we'll touch on this a little bit because there's particularly one PCGML machine learning based PCG approach which has gotten some success in indie game design. Okay, so constructive methods. I'm going to talk about all these topics in more details later. This is just a high-level overview. So basically all constructive methods can be thought of as requiring building a grammar, which is this original concept from linguistics, right? You've probably all taken a grammar for some language before, right? Languages follow rules. That's the basic idea. And the idea here is that each grammar is composed of two parts: tokens in a language, that's individual words, right? And then rules for how these things can fit together. So in language, we think of these things as like, how are we allowed to string together sentences? What makes a valid sentence, right? In PCG, these tokens would be things like individual pieces of content and the rules for how they connect together. So, oh, that's not, oh, right, sorry. I completely forgot what this slide was going to be. So 3 high-level approaches for constructive PCG: cellular automata, popular a while ago; a generative grammar, which is the most popular current method in both indie and AAA PCG. This is the majority of approach; and constraint satisfaction problems, which are niche, but becoming less so. So cellular automata was originally developed in the 1940s and then finally sort of made famous by Conway's Game of Life, if you're not familiar with that, from 1970s. It's a fun little watch. We want to see a quick example. Let this load and then pop over to here. You can see a quick example of this with terrain. The basic idea is we have little local rules to say like, hey, what should happen? What are like allowed local relationships between things? So we would start with like some random noise like this. And then if we were going to generate a maze, we'd have a series of rules that would check all that sort of like local area and would try to make it consistent with this notion of a maze. So you can watch it happening in big updates. There it goes, 1, 2, 3, 4. And every time you can see the sort of structure of a maze slowly coming together. It's like a magic eye puzzle. Here it's coming, it's coming, it's coming. All right, looking more maze-like, looking more maze-like. It's not going to quite finish, but if we jump all the way to the end, you can see we basically have something that looks pretty maze-like, pretty reasonably like a maze. Now, this is all based on local updates, individual pixels in this case, checking their neighbors and saying like, hey, is this an allowed setup, right? Because we're basically saying, okay, we want either pixels to be part of a hallway or to be part of it like a turn in a hallway or a wall or things like that. So when we have things like, this section here, which is just this big, it's hard to tell, but just this big like black chunk, anywhere you see on the screen, anywhere you see this like big, like, here's a good example. Here at the bottom left corner, you can still see a lot of these. So these just like clump of black pixels, which is not what we're after here, right? We're after these sort of purple and black mix. That's the notion of where the update hasn't yet occurred. So that's what it looks like. And a high-level notion of how does it work. But the basic idea is that we're local decisions, which are going to percolate through the content until some hand-defined stopping point. Now, there's no actual guarantees for anything like this that the end result is going to be playable. There's no guarantees there. But it's really easy to set up. So on the top right corner, I have an example of a cellular automata cave that I threw together in like 30 minutes. I'm not going to show you that today because we have so much to go through, but if you're interested, we can talk about it later. Second of these approaches that we're going to talk about today are generative grammars. So this works for things like Spelunky, where the way that Spelunky's worked is that they, Derek Yu had hand-defined a whole bunch of individual sections and given them names. And then there were rules about how could these things be put together. So like if you have a drop has to be something below it, right? That was like a rule that was in the original system. And then it could like piece together things piece by piece, one at a time. Similarly, with No Man's Sky, this is a very early draft of No Man's Sky, which is why the creature looks so funky. But you can, I like this example because you can very clearly see the distinct parts, right? This head is a distinct part that was authored by a human. The torso was a distinct part authored by a human. And the legs, the front legs and the back legs are also distinct parts, right? And then there were rules about how you could put those together. But you can see even here where those rules don't exactly work, right? This thing looks very silly. And that's not the intention. Intention is not to produce silly looking creatures. So there were iterations that would have to be made on the rules and the tokens to make sure that doesn't happen. So generative grammars are well suited for small stories, levels, creatures, etc. Game Maker's Toolkit has a whole video on how and why Spelunky makes its own levels. We don't have time to go over it, but I recommend it if you're interested. It's basically a video version of that book. It's typically done in a single shot with no backtracking or altering when something's generated. So we would just go piece by piece. So in a Spelunky level, we might go from like top left to bottom right. For a creature like this, we might go from like head to tail. Though I think what they actually did was torso out in this case. And then finally, they're time consuming to get right. We'll go over an example of this, of like how difficult it is to get a generative grammar to work in like a real case in a while. But first, I wanted to show you a pretty trivial Unity example, just to give you a sense, how does this thing work? So I've made this extremely simple, tiny little Unity thing. I will include this with the lecture things if anybody's interested in it, but it's so dang simple, it's not even like really worth it. I'll move you out of the way. Can I actually get this fully off screen? No, I can't. That just lives here. Where can I put this where it's the least bad? That works. So if I just hit play, then we get this quote unquote statue that's being generated. What's happening here is we have a base and then we have different parts of it. If I hit play again, my default microphone has changed. That's not ideal. If I hit play again, right, we have a slightly different quote unquote statue here with slightly different colors for each of these spheres. Do it again, etc. Right? So every time it's very slightly different from the time before. Let's actually take a look at the code and see what's actually happening here. So we have our quote unquote statue builder. Get that loaded up. Hey, can I please? Thank you. Visual Studio will take a second. There we go. So that was not what I wanted. So here's how this is working, right? So we have our statue builder script here. We have a statue components. That's just an array of possible pieces of this statue. These are just like tokens in this case. We have the size of the statue, how tall the statue we want to be. So it's just a rule, right? Then we have a system obsolete. That's not what I want. Anyway, not important. Then we have this function to spawn components. We put it at a particular location, right? And then we spawn some more components. And that's it. We're spawning you can see here, the thing at index 0 of this. That's clearly the cube. And then we're spawning spheres here. Okay? That's it. That's the whole script. So this is pretty simple. I don't have explicit if-else rules here yet, but there's a whole bunch of implicit ones, right? In terms of if you hit 5 in length, in terms of the statue, stop. You're just done. And if previously there was a cube, then next there has to be a sphere. And if previously there was a sphere, there has to be a sphere, right? That's the way we can think about this in terms of rules and tokens. The tokens being the pieces of things. If we want to make this more interesting, right, a little bit better, we could add other rules here. So for example, we could do something like say, if our prev ID, which I have here, if our prev ID was a sphere, which is what that's telling us, then maybe instead of spawning yet another sphere, what we'd want to do is spawn a cube. So I've made, a small change. I've added an explicit rule, and this is just the implicit rule that we had previously. And if we do this, right, what we're going to get is pretty straightforwardly cube, sphere, cube, sphere. It's not great by any means, right? But I think it's starting to look somewhat more like a real statue that you might actually see. So let's take another look at this. So what if, for example, something we haven't looked at all yet is this picking a random color thing. So all this is doing is it's picking from a set. No, I don't want that right now. Picking from a set of color possibilities that are on each thing. So this is also a set of tokens, right? A set of tokens we have to define, each of these distinct colors. And then we have no rules, just no rules. It's just whatever you get is what you get for each of these. And right now, these colors are awful, right? They're extremely rough color-wise, especially if we're trying to make this be, some kind of believable statue. So what we can do here, right, is change the tokens. So I could change our tokens to instead be, maybe a little bit more believable as like statues. So maybe we have like a brown, a silver, and something copperish. So now if I rerun it, we can see that we have something that looks like this, right? Which is starting to look a little better. So by making these sort of iterative changes where we make changes to tokens, we make changes to rules, we can start moving from something that initially looks like garbage to something that looks like more like what we want, right? And we can see that if I'm hitting, play over and over again, that we're going to get different variations of this. Now, they're not hugely different, right? They're all pretty much the same, but they're still fairly distinct. So if I wanted, I could add more rules. I could add more variance by adding more tokens, more sort of random options of when to choose between things. But it's a trade-off of like, how much structure do I want to enforce here versus how much emergence of possible things do I want, even if some of those things may look a little bit funky. So that's the basic idea. I just want to give you a high-level notion of like, what's it like to iterate on a generator? And with that, PQ2, I've been talking for too long. Pretty straightforward question. When do you think it's appropriate to employ PCG in a game? You've only seen one type so far, right? This sort of constructed PCG that I've given you this example of. But hopefully you can sort of get the gist. This is a very set notion of sort of iteratively working on a generator, seeing what spawns, and continuing to update like this. Okay, been a couple minutes. Let's see what people have said. That's not right. That's not the right window. All right, we got some responses. Let's see. So when do you think it's appropriate to employ any game that needs lots of levels and can iteratively change, get harder as the user gets better at the game? I think this is a reasonable answer. If you want to do this sort of like player adaptation, player modeling, then yeah, having PCG at some point makes a lot of sense. And most games that have PCG do have some kind of implicit player modeling in terms of trying to make you a level that matches you. When one wishes to make the world at random, dynamic, and unique, but still follow a set rule set, I also think that's a reasonable answer. When you want players to have unique experiences, that could reduce churn because players may want to keep playing the game over and over again without getting bored. So I think this is true, but I would put a caveat on it, which is to say that yes, it can be helpful in terms of producing unique experiences every time, but it can also lead to a problem where the experiences just feel random. It's much easier actually to produce PCG content that just feels random, that doesn't feel like structured or interesting to keep engaging with. That was part of the revelation, the importance of Spelunky was in showing like, hey, you can use PCG and you can still get stuff that seems like a human made it. For generating lots of content for a small time investment, this I want to really caution you against. Small time investment is not true. I set you up with a simple statue example, a really trivial example of like, how could I make something that looked kind of bad and then make it kind of good pretty quickly? That's not the case for more complicated content. It's as hard for more complicated content.
When there are game objects that can easily be split into modules and each module has many viable variations, sure, potentially. To make unlimited variations of unique costumes in a game. You could do this, but again, you run into the same problem of a lot of the content you're producing is going to seem like garbage. It's just going to seem random. It's not going to be interesting, right? You see this right now with all the terrible, no good, very bad NFT stuff, where it's just like, we're going to throw a whole bunch of random nonsense onto this, and it looks awful, and it's destroying the planet. So, you know, it's a lose-lose. Behavior for an enemy NPC. Behavior for PCG is actually extremely difficult. Almost nobody does generated behavior. We can talk about why if that's of interest later. Okay, so I think overall some pretty good answers here. Let's jump back into it. Okay, so my answer is definitely not always. My answer would be when there's an existing tool like SpeedTree, where we can just sort of plug and play, right? We can just use this thing that already exists. Or when you're trying to create a game that would not otherwise be possible without PCG. These are the situations where I would suggest applying PCG. Otherwise, it's too much of a time investment most of the time. Even then, I do recommend, even if your game requires PCG, to be aware of how much time it takes. PCG does not save time in developing games. This is a weird rumor, a weird lie, and it's an easy lie to want to believe. But it takes so much time. Remember Mass Effect Andromeda. Never forget, 3.5 years down the drain. It takes a lot of time to get PCG to be good. And sometimes, even after all that time, it's still not very good. Okay, so that brings us to constraint satisfaction problems. So these are largely not used in indie or AAA game design, just at all. But they're really powerful. So Refraction was this game, which was like this edutainment game created by the University of Washington. And they used CSP, constraint satisfaction problems, because they just had one of the world experts of constraint satisfaction problems working there at the time. But they're really well suited for games where precision is key, or things like puzzle games. Because the idea is that you're going to enforce particular constraints on your content. It has to follow those constraints. It's basically a dense collection of rules. You're going to hear rules a lot for these first few approaches, where each slot stores every possible solution until there's only one possible solution. So let's look at a quick example, because I think this is a way easier way of grasping what the heck is going on with CSPs. So let's say that this was our setup. Here's all of our slots, right? It's a 4x4 grid. Here are all our possible tokens. We have a clip art mushroom, sky, ground, and flower, okay? And here's our rules. Ground cannot be above the sky, because that doesn't make sense. We're not talking about like Laputa Castle in the sky here. Mushroom can be above ground, correct. Flower can be above ground, correct. Ground cannot be above flower, and the flower either has to have another flower or the sky next to it. Okay, these are all our rules. So the way that it works is when we start at sort of time step 0, every single token is in every single location. There's a lot of CSP, sort of constraint satisfaction people, who will make sort of references to quantum physics, because the similar notion of like multiple things in the same location. It's not really quantum physics. Don't get excited about quantum physics here. But the basic idea is that we're going to have basic 2 steps that happen for CSP. The first one is the decision. So we're going to pick one slot, and we're going to collapse it down to just a single option. So in this case, I've just picked this one right here, and I've said, hey, that's going to be a flower. Then because of that decision, there's then going to be some implications. And these implications come up from the rules. So what I just did, right, you can see at the above the flower, because the flower cannot have the ground above it, right? I'm saying, well, if it can't have the ground above it, and mushrooms have to be above the ground, above a piece of ground like this, the only thing that can be above the flower now is sky, right? So it's like by process of deduction, it has to be sky. Then we go again. We have further implications. So beneath the flower, because of this rule right here, it has to be ground. And that might have then further implications, right? Which you can see below it. I didn't do this as a separate step, which I should have done. But because ground is here, right, that has to mean that it's ground beneath it or a mushroom beneath it. Because again, the sky can't be below the ground and flowers can't be below the ground. Yes?
I'm not sure I'm finding out the rules. Could you theoretically, like, with these rules, like, have the flower above a sky panel?
No, this is a hard requirement. This is a hard constraint. Make sense? Okay. So then we do a decision again, right? So typically the way that you pick for a decision is you pick the single location that has the fewest possibilities, right? This is, again, a heuristic, which is the best possible thing. And in this case, it's the one directly below the ground. Let's say that's a mushroom. In this case, there's no implications from that because there's no rules about things that happen to the left or the right of the mushroom, and otherwise we're at the bottom of the screen. From there, we keep on going. Decisions, implications, etc., until you hit some final state where there's no longer any other options. Everything only has one value in it. So this is a possible viable one, and this looks fine, if a little boring, but you could also have gotten this one from the same setup, that same starting point that you saw earlier. This was a lot more interesting, if a little bit weird, potentially. And so it's be up to the individual author to say if this is okay for the generator to generate, and if it's not, to add more rules to say, why isn't this okay? Make sense? Cool. Okay, so CSP issues. There are some. It's hard to get a good set of rules, right? Over-engineering versus emergence is a thing that we've talked about quite a bit. And you have like rule-based systems, like in the dialogue we mentioned earlier. It's just as true here. If you over-engineer, you're going to constrain your possible output to like a very small set. But if you leave it too open, maybe you have things that you're generating that you don't really want. So hitting that balance is tough. It also tends to take a lot of rules for complicated things. I don't think I wrote this down anywhere, but like a very simple like arcade game constraint generator had like 300 something rules in it for generating things that looked like stuff that wouldn't even fit on Atari. That was like simpler than that, like McDonald's games. You know the ones with the Happy Meals. Maybe you don't know the ones. That might be after your time. So potentially slow as well. So with more rules, it obviously gets slower because there's more things to check. But also, you can run into a problem with backtracking. This is something I didn't mention earlier. But essentially, we can get to a position where it's no longer possible to have a final solution because our constraints just don't allow for it. And if so, we have to backtrack until we hit a point where it's possible to have a solution again. And that can take a long time to do generation. We'll have more on constraint approaches after reading week. Okay, and then the final approach we're going to talk about today is search-based methods. So the basic idea of a search-based approach is we're going to define some space, S, where every element, E, which is just a point in the space, is a valid piece of content, which can be difficult to think about. But imagine, a point in a space, right, where every single point in that space is itself a piece of content. It may not be a good piece of content, but it's a piece of content, whatever you're trying to make. And then we're going to look through that space with some kind of heuristic, or it's often called a fitness function for search-based PCG. Fitness, right, is just a function that takes in whatever our content is and then gives it back some number to recognize its quality. And the idea is we're going to try to find the piece of content that has the highest quality. Search-based methods are generally not used in the industry or indie game development. There's like a few examples I'm going to be able to point to that are mostly academic, same with constraint-based approaches. So these are like genetic algorithms, so like Darwin's Demons, which is buyable on Steam if you like. Darwin's Demons is a game where as you use a particular weapon, the system is going to try to evolve that weapon to be more like things that you want. So it's going to be changing the weapon as you're playing, and the more you're using the particular weapon, the more it's going to say, oh, you like that, right? It's like the fitness function. You are acting as the fitness function to say, this is a good weapon, and to keep on generating weapons like that. Petals was a short-lived Facebook game, if you remember Facebook games. And this idea was that each flower was itself procedurally generated, and you could trade flowers around and generate new flowers by like mixing flowers, seeds together, and things like that. It was, again, both of these are academic problems, or academics approaches, and they both are using genetic algorithms, which is a particular kind of search-based PCG. It was by far, still is by far, the most popular search-based method. It's also called evolutionary search because it sort of takes inspiration from evolutionary search. Again, don't get excited. There's not like actual evolution happening here. Hello? Can I click? Hello? Okay. It's a popular search method in out of games inspired by Darwin's theory of evolution, very loosely again. And again, we'll have more on this topic after reading week. In fact, this is going to be assignment 5, just as a little like prelude trailer. Okay. We don't really have time. We only have 7 minutes left, but I was going to have you ask a question of, hey, what's a good measure of quality for game content? So just take a second and think about that. How could you decide for a particular kind of content, whether that's levels or stories or characters or behavior, if it was good or not? How do you turn that into a number, right? It's really hard. My answer for this, which is the whole joke setup, was going to be, I don't know. People don't know for decades how to do this problem. People have tried to do this thing. It's extremely difficult to come up with a function which takes in a piece of arbitrary content and returns how good that is. It's equivalent with being able to say we can predict how fun something's going to be, right? That's really hard. As far as I'm concerned, it is functionally impossible to do in a general sense. So that produces some issues, right? It's really hard, again, to get a good measure of game content quality. They can also be slow, potentially as slow, if not more slow than constraint-based approaches, depending on the particular search-based PCG approach. Again, more on this after reading week. And they're much more difficult to control than constructive methods, because all you get as a designer is the heuristic as a way of impacting what gets generated. Unlike with constructive approaches, right, with like constraint approaches where you can author more rules or change the tokens. You can't do that here. You don't have that ability. Again, more on this after reading week. Okay, so there's a ton more stuff out there, right? Chapter 4 of Yannick and Julius. There's an AI in Games YouTube, which has videos on PCG. And there's a whole bunch of conferences. If we have to talk about game AI, academic game AI, then I'll cover some of this stuff. Okay, so quiz comes out tomorrow, 11 a.m., due on Sunday. Here's the topics that I want you to be able to implement / walk through. So they are model-based player modeling, all of those. The k-means, k-metoids, right, because it's assignment 4, you should be able to do that. GMMs, Gaussian mixture models, single linkage clustering, k-nearest neighbors, linear logistic regression, and decision trees. So quite a bit that's potentially on offer for the quiz this week. Topics to just remember. I'm not going to ask any like specific things, but I want you to remember how like spatial representations, path planning, and decision making works, because I might ask some questions that touch on or assume that you know how those things work. Any questions on any of these things? Any clarifying stuff? You can also ask me questions on Discord before the. Whoa, hello, that was weird. Sorry. Can I do this? Hello? Okay, that worked. Any questions on any of these things? I don't know if the Zoom people have any questions as well. Of course, my face has frozen again because Zoom hates me. Oh, maybe the Wi-Fi is mucking up. Are the Zoom people complaining? No? Okay, no, I'm getting chats. All right. Also, feel free to show up tomorrow or on Friday for the help sessions. The quiz will be released, which means that I can't go over theoretical or fundamental questions, but I can give you high-level notions. Can I go over a linear logistic regression example? Going to be hard to do with my camera dying again, but let's reopen that and at least go over it this way. Right, so the basic idea of like a linear logistic regression is in either case, we have a particular function, and we're going to try to come up with the parameters of that function, which are going to most closely fit some data. So for linear, this is the best fit line. If you want to look up something like that, it's an easy way to think about it. For logistic, right, we're again changing parameters, but it's just this parameter, basically, to be able to tell us where does this sort of S-shaped thing go? Where is it relative to the data? I can't go over it in more detail than that, apologies, because I don't have a working camera. If you'd like more information than that, ask me again on the Discord and I'll be able to like send particular links and suggestions. Anything else? Okay. Well, if people are already packing up, I will take that as a sign that you all feel extremely confident on these topics. So we can go ahead and end here. If you want, you can come and ask me a question afterwards individually, or again, shoot me a message sometime today. I am releasing the quiz tomorrow at 11 a.m., Naheen, as I've mentioned a few times now. That's to help the people with reading week, a desire to actually take reading week off. Truly don't know why Zoom is just like, you cannot have your camera on after a certain point. Ugh, how annoying. All right, everybody's gone.